is opening for me. I mean, it was seemed like on demand. Yeah. Check once. No? Okay, fine then. Fine, so. Okay, I'll try it. Okay. Hey guys, what's up? A very warm welcome to all of you. I hope all you guys are having a super amazing day going on. I was just opening my video and I'm watching ads for my own video. I'm like, YouTube bro, what is this? Huh? For watching my own video, I'm watching ads. Huh? So what's up guys, I hope all of you are ready for this insane amazing session, because this topic is something which I have been waiting for a very long time to teach you guys, but I didn't get a chance to do it. So today I am here with a sick throat and a runny nose, but still we're gonna rock this class guys. You might notice my voice has changed a little bit. It's just because of cold. Just bear with me today guys. So if you're new here, today's session is all about grade 8 CV ICSE atomic structure science, but doesn't matter if you're from ICSE, CBSE, Maharashtra board, state board, that board, this board, it doesn't matter. This is the basics of chemistry. You all have to learn this, and it's very important. So if you're new here, do not forget to hit on the subscribe button, and a warm welcome to my class. My name is Mohan, Master Teacher of Science from Vedantu, and a very warm welcome to Vedantu Young Wonders as well. So are you all ready, people? Are you all ready? Hi Olympiad Knowledge, hi Knowledge Journey, hi I'm great, hi Defina, hi Mona Lisa, hi BTS Girl, hi Anshu. Lot of new names today. Welcome to the class guys. Good to see you all here in the class. Good to see you all. I am doing great guys, I am doing great. I am waiting for this video since many days, since finally, yeah, because I was sick. I am still sick, and I was like, let's not delay it anymore. Let's just take it. Hi Rishabh, hello. What's up? I'm waiting. Okay, cool. Hi Purple Student. Hi Blue Warrior. Hi Defina. Of course I remember you. Hi Charita. Hello. Okay. Cool. Amazing. Great. Okay guys, so before we actually get into this topic, there is something very important that I want to tell all of you, is that this chapter is the basics of your chemistry. Many of you guys are still not aware about what are all the different things that is there in atomic structure, and it's very important that you guys get to know. It might not be there in your grade right now, but you will be studying about it in your higher grades, so it's very important you guys all focus on it. Okay, is there Menti? There is going to be VQUIZ hopefully. Okay, the VQUIZ seems to not work today, but let's try anyways. If our luck is good, it'll work. Okay. Cool. Let's start guys, You all ready? Great guys. Before we actually get started, the different topics that we'll be covering right today is we'll be learning about what exactly are subatomic particles, atomic model, electronic configuration, atomic number and mass number. This is what we'll be learning right today guys. But before we get into all of these topics, one thing we all have to understand is, sir, what exactly is an atom? Right? We all know that everything around us, be it this phone, be it this table, this laptop, my water bottle, everything is made up of atoms, right? Atoms are the building blocks of matter, be it anything, right? For example, you might have all studied like this. If you cut me into two, I'll become two. If you cut me into four pieces. If you keep on cutting me million times, there will be one point where you cannot cut me anymore. That is the point of atom. Right, that is what people were thinking. They were thinking, okay, you can divide a product as many as times you can until you reach the atom. After atom, it's nothing. God knows what is there after atom. That is what people were thinking. But is atom really indivisible, or is there something inside the atom also? Is what we are going to try to understand in this chapter. Okay, yes, that is what we'll try to understand. Now, one very good example for us to question that there is something inside the atom which has certain charge is this repulsion and attraction experiment of electrostatic force. So one of the first indications that atoms are not, indivisible comes from static electricity. So static electricity means what? It refers to the imbalance between electric charges in a body, right? Specifically the imbalance between a negative and a positive body. Right. Olympiad in fingertips. Aram se. We are learning one by one. Don't disturb the class. Okay. Right. So that we'll try to understand, guys. So when we all know that whenever you rub two objects, the objects get charged. Right? One object becomes positively charged, and the other object becomes negatively charged. So how is this charging happening? Now what are these charges? How is entire, different attraction and repulsion forces created between two objects when we rub them against each other? It all has to do with what exactly is happening inside the atoms. In fact, atoms are divisible and they contain protons, electrons and neutrons. These three things are present inside the atom. How cool. We think atom itself is very small, but inside the atom we have these subatomic particles present inside them. Yes. Why are they called as subatomic particles? Because atom subatomic inside the atom. Isn't it so cool? But how did people even find it out? Right? So we'll be learning about what is subatomic particles, electrons, protons and neutrons. Also what is atomic mass and mass number. The structure of the atom, atomic models, Thompson's model, Rutherfords model, Bohr's model. So all of this we'll go through one by one. Okay, we'll come to that bit. I will come to that. You guys are jumping to the last step. Wait. Okay, first, let us see how electrons were discovered. Okay, electrons were discovered by whom? By J.J. Thomson in the year 1897. Okay, Olympiad fingers, I'm going to get you blocked. Stop spamming in the chat box. We're going step by step. Listen, if you don't have patience, leave the class. Right. Got it? 1 second, please. Great. Alright. So, this discovery of electrons was made by J.J. Thomson in the year of 1897. What did he do is, he conducted a very cool experiment. A cathode ray experiment which was very, very cool, because what he did was, he passed cathode rays inside a tube. Now what happened, because we all know this cathode rays are nothing but what? They are negatively charged particles. When these cathode rays started striking the other end, it started glowing. So in this experiment, he was able to tell that there is a presence of negatively charged particles. Now those negatively charged particles are nothing but electrons. So electrons carry what charge, guys? Negative charge. What about protons then? Same kind of experiment was done by E. Goldstein, who showed the presence of protons, which are basically positively charged subatomic particles, which is protons. Okay? Yes? Now, discovery of neutron. What about neutron then? Again, the discovery of neutron is another subatomic particle by James Chadwick in the year of 1932. Got it? Now let's talk about the characteristics of electron, proton and neutron. First, we all have to understand electron consists of negative charge, right? Proton is positive charge. Neutron is neutral, doesn't have any charge at all. Isn't it? Now, let's talk about the charge of electron, -1, negative. Proton +1, neutron is 0. Relative mass is 0 for electron. Then we have proton 1 and neutron 1. Got it? Now, how are these electrons, protons, all of these neutrons are arranged within an atom? How are they placed inside the atom? This became a very difficult question in those days. People were scratching their head. Okay, we found out that there is electrons. We found out that there is protons. But how are they arranged inside the atom? Is there a way that they are arranged inside the atom? Yes. That is when people started, doing a lot of experiments. Beta, I will not take class in Hindi. Okay, this is an English class. Okay, stop spamming, guys. Today, why is there a lot of spamming today? My God, why are people spamming a lot today? What is happening in the class today? Exactly, stop spamming. Relax, calm down. My God. Okay, now first comes our hero, Thompson. Okay, so Thompson thought, how many of you guys know watermelon? Watermelon, you guys know watermelon? So inside the watermelon, what do we have the most? The most irritating part is the seeds, right? There are seeds everywhere. You're trying to enjoy the piece of watermelon. There comes a seed. You don't like it, right? So what Thompson's thought was, Christmas. This is also called as a Christmas, a pudding model. So what happened is, he told the entire atom is like a sphere, a ball. Okay, it's a positively charged ball which contains electrons here and there. That is like, it's for example, if you take a watermelon, the entire watermelon is like positively charged. The seeds are negatively charged. That is what Thomson told. He told this is how atoms, subatomic particles are arranged inside it. He told they're neutral also. The negative and positive charges are equal in number. So the atom itself is entirely electrically neutral. Now people were happy. They are like, yeah, no, it can be. It can be like watermelon. It can be like a pudding cake. What is wrong in this? That's what he thought. But then there were a lot of drawbacks also. So Thomson's model explained that atoms are electrically neutral, but when other scientists carried out their experiments, they were not satisfied with it. One such person who was not satisfied is Rutherford. Yeah, Rutherford came with an amazing experiment, alpha particle experiment. So what he did, he took a thin gold foil. He started passing alpha particles through it. Alpha particles are high energy particles. So he took an alpha particle ray gun and then he passed all that alpha particles towards the thin gold foil. Okay, why gold foil? Because gold foil can be made as thin as possible. That's the metal which you can make as thin as possible. So he started passing through it to observe how these alpha particles are reacting with the atoms present inside the gold foil. He observed these things. See, he observed small deflection. In some places there was no deflection at all. The alpha particles passed through directly. In some places there were deflection, they were deflected right back. It's like throwing a ball on the wall. It just came right back. In some places there were more deflection. This is how the alpha particles were scattered by the gold foil. Right now this made him, a little confused. He observed that most of the fast moving alpha particles passed straight through the gold foil. Nobody could stop them. It was like there was nothing to stop the alpha rays. So some of the alpha particles were deflected by the foil by small angles. But surprisingly, 1 out of every 12,000 particles appeared to rebound. They all came back. 1 out of 12,000 rebounded back. From this, Rutherford came to a conclusion that most of the space inside the atom is empty. That is why the alpha particles were passing directly through it. There was nobody to care about these particles. It's just empty. And there were very few particles which were deflected from their path, indicating that the positive charge of an atom occupies very little space. All the positive charge and the mass of the gold atom were concentrated in a small volume within the atom. So he told the entire mass along with the positive charge, all of it is present in one place inside the atom. He also calculated something very fun. He calculated that the radius of the nucleus is about 10 to the power 5 times less than the radius of the atom. He said it's very, very small. Even though the atom itself is small, the nucleus is even smaller. 10 to the power 5 times lesser than the radius of the atom, which is very tiny. This is what his conclusion was, looking at how these alpha particles were going. Okay, so the postulate was, he told there is a positively charged center which is called in the atom, called as the nucleus. Nearly all the mass of the atom resides there only. Electrons are going around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of the atom. Is this model correct? Is this model correct? What do you guys think? Hi Liso, hello. Hi Blue Warrior. Hi Rahil. Yes, gold is very malleable. Is this model correct? Tell me guys, quickly. Quickly people. Quickly. Is this model correct? Looks like correct, right? Yeah, that is what we have studied. No, there is a nucleus, there's electrons going around it, but no, because Rutherfords model doesn't talk about where the electrons are going. Are they going in same path? Do they have a specific path? Nothing. They were drawbacks. He explained that electrons in an atom are revolving around the nucleus, right, in well-defined orbits, but particles in circular orbits will experience acceleration. They are moving forward. Thus, the revolving electron will finally lose energy and fall into the nucleus, right? It should lose energy and fall into the nucleus. But if that happens, atom cannot be stable. Atom would be unstable. And none of the things will exist. So he was not able to explain this part. But then, who came next? Who came next? Charita, they are high energy particles, Charita. Okay? Who came next, guys? Tell me. It was Bohr. Bohr's model of an atom. So he told only certain special orbits known as discrete orbits of electrons are allowed inside the atom. So, electrons are not randomly going in circular orbits. They have their own separate discrete orbits. While revolving in discrete orbits, the electrons also are, they are not at all radiating any energy because they are going in their own orbits. Only if they are radiating or losing energy, they will fall into the nucleus. But since they are revolving in their own fixed orbits, they are not radiating energy. Okay, and those orbits or shells are called as energy levels. There are different energy levels. That is what we call them as K shell, L shell, M shell, N shell. So all of these are different levels that we have. Got it? Yes. So the maximum number of, let's talk about how these electrons are arranged inside the atom. This is very important where most of you guys get confused, right? So the maximum number of electrons present in a shell is given by the formula 2n to the power 2. N is your orbit number or energy level, which is 1, 2, 3. This is it. 1, 2, 3, 4. So 2n to the power 2. Okay, first orbit is your K shell, which is 1, right? So 2 into 1 to the power 2, which is equal to 2. So how many electrons can be present in the first orbit? Only 2. Second orbit, your L shell, which is 2, right? 2 into 2 to the power of 2, which is equal to 8. So 8 electrons can be configured inside the second orbit. Third orbit, M, which is 3. So 2 into 3 to the power of 2, which is 18 electrons. The same goes for N shell and so on. This is how the electron should be configured inside the atom. Got it? And the maximum number of electrons that can be present in the outermost shell, outermost orbit, is 8. So electrons are not accommodated in a given shell unless the inner shell should be filled. Okay, first all of this shell should be filled. After 1 is filled, then 2, then 3, then 4. It should go in order, guys. Okay, the cells are filled in the stepwise manner. Got it? Now, so the number of electrons plus is equal to number of protons, which is your atomic number. What is the atomic number of an atom? That is your number of electrons present in it. Okay? Yes, you can ask me a doubt. Tell me. See, these shells are different energy levels, guys. Okay, purple student? Those are different energy levels that we have. So what is atomic number? Number of protons, which is equal to number of electrons. Okay. Now, examples of electronic configuration. Look at this. Helium has 2 electrons. So obviously, we can just fit it in the first shell itself. Okay. And next one. Let's talk about lithium, which has 3 electrons. So it is 2, 1. 2 in the K shell, the remaining 1 in the L shell. The same thing we can do for oxygen, which has 8 electrons. So 2 in the K shell, the remaining 6 in the L shell. Okay? Yes. Then for calcium, 20. See, 2 in the first shell, that is your K shell. Then comes your L shell, which has 8. 3, 4, 5, 6, 7, 8. Then comes your M shell, again, which has 1, 2, 3, 4, 5, 6, 7, 8. Then comes your N shell. So like this, we can arrange the electrons inside the atom in their own respective shells. Got it, guys? Yes. So similarly, we can find for all the first 20 elements. If you want to have a look at this, yes. Helium, lithium, beryllium, boron, carbon, nitrogen. For everything, it's given here. Sir, I have a doubt. You are ignoring me. You are ignoring me. Listen to what I am teaching. Correct, Rahi. Number of protons present in the atom is atomic number. Correct. Okay. Now, what are valence electrons? What are valence electrons? The electrons present in the outermost shell. Look at this. 1, 2, 3. So these are the valence electrons. The outermost shell is also called as the valence shell. You have protons, you have neutrons in the middle. Then you have the first shell. Then you have the second shell. Okay. Now this gives a combining capacity of atoms or their tendency to react and form molecules with atoms of same or different elements. Okay, so these electrons present in the valence shell are the reason why we have different atoms forming molecules together. For example, sodium chloride, it's forming. Right? Similarly, we have many different atoms forming molecules together because of the valence electrons present in it. Okay, look at this. Here, for sodium, the valency is what? The valency is 1 because in the outermost shell, what you can find is only 1 electron. Right? That is your valence electron and your valence shell. When you talk about aluminium, see how many electrons do we have in the valence shell? 1, 2, 3. You have 3 electrons in the valence shell. That's your valency. Next, for phosphorus. Right? Now look at this. For phosphorus, you have, if it's more than, it's 5 and more than 5, right? So it is 8 minus 5, you have 3. Look at this. For the first shell, 2, second shell, 1, 2, 3, 4, 5, 6, 7, 8, then 1, 2, 3, 4, 5. To complete 8, how many electrons do you need? 3 more. So 3 is your valency. Okay. Now, for, yes, look at this. Now you have 8 here. It's completely full, so valency will be 0. In the same way, you can see for all of the elements. Let me make myself small so you can see it. Please have a look at this, guys. For everything, for hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. For everything, guys. Got it? Great, guys. Now, atomic number. What is atomic number now? The total number of protons in the nucleus of an atom gives the atomic number of the atom. It is represented by the letter Z or Z. All the atoms of a particular element have the same number of protons and hence they have the same number of atomic number. Atoms of different elements have different atomic numbers. For example, all carbon atoms have atomic number of 6, whereas all the atoms of oxygen has 8 protons in their nucleus. Okay, so the number of protons defines your atomic number. Mass number is number of protons and neutrons together. That will give the mass number. So protons plus neutrons is your mass number. Only protons is your atomic number. Okay, so the atomic number is represented by Z. The mass number is represented by A. Okay, so as both protons and neutrons are present in the nucleus of the atom, they are together called as nucleons. The number of nucleons is your mass number. For example, an atom consists of carbon has 6 protons and 6 neutrons, so its mass number is 12. The weight of the electron is almost negligible, thus the atomic mass of the atom is almost the same as its mass number. For example, this is how it is represented, guys. Whenever you see a chemical, so on the top you have E, that is your mass number. On the bottom you will have your atomic number. This will be your symbol. Okay, this is how a chemical is represented along with its mass number and atomic number. So whenever you see any chemical represented with numbers, you should know what the number represents. Okay, for example, look at this. For helium, atomic number is 2, mass number is 4. The element ka symbol is He. Same goes for oxygen, right? Oxygen's atomic mass is 16, atomic number is 8, so a chemical symbol is O. Okay, there are something called as isotopes, which I'll not be covering detailedly now. Okay, you'll be learning about it in your higher grades. So which will have same atomic number but different mass number. So your atomic number will be same, but your mass number will be different. Okay, for example, carbon 12, carbon 13, carbon 14. So these are the isotopes of carbon. Because look at the neutrons. Neutrons numbers are changing. One has 6 neutrons, other has 7, other has 18. So 8. But protons remain the same. That means your atomic number is same, but your mass number differs. Please do some fun. Shall I dance, Anirudh? I'll do some fun. My God. So all of this will not cover right now, guys. Okay. And let us also find if you have VQUIZ by the end of the video. We'll see if it is there. Let's see if the VQUIZ works, guys. It is working. Okay, so guys, you guys can go ahead and play this VQUIZ. Just enter www.vquiz.in. Sorry, vquiz.in, and then go for 2278844. This is your code, guys. Check this out. Okay, let me see if it is working. Wait. Yes, so VQuiz is not in the description, guys, but I'll tell you how to join. So you have to type www.vquiz.in. Okay? So type vquiz.in and enter the code 2278844. That's your code. Okay, enter it. Then click on submit. Then log in, you'll be able to play the quiz. Okay, so please make sure that you guys play this quiz to understand, to see how much you have understood in today's session, guys. So I hope all of you had fun. We'll definitely meet up in the coming session. Okay, and make sure that your scores in the comment section. Put down your scores in the comment section. Also, let me know the doubts you have in these topics, so we can again elaborately cover those specific topics clearly. Okay, fine, guys. So I hope all of you had fun. We'll meet up in the next class. Until then, this is me, Mohan, signing off. All of you take care, stay safe, stay as lovely as always.